Good morning, everyone, and welcome to my PowerPoint on equivalent fractions. So, this is just a starter activity for the rest of this video. We're going to look at equivalent fractions and adding and subtracting fractions, a subject that you have done before, but I want you just to look at it again and make sure you completely understand this. So we're going to look at this week lots of different activities to do with fractions. Okay, well, you can see what fraction I've coloured in here. Yep, you can see I've coloured in a half. You can also see that this fraction is 2 out of 4, so I've shaded in 2 quarters. You can see that they are exactly the same amount that I've shaded in. So a half is equivalent to 2 quarters. And you know that whatever I times the numerator and denominator by, say in this case, if I times them both by 2, I will get my equivalent fractions. So that is basically what equivalent fractions is about, where fractions are exactly the same amount and you times the top and the bottom, the numerator and denominator of the fraction to get the new equivalent fraction. So little starter activity on this. So what would be, I'm going to get a different colour pen, what would be the missing here? Have a go. In fact, have a go at both of those two. Pause and then let's go through them. So we're going to times by 2. Going to times by 2. 3 times 2 is 6 and 1 times 2 is 2. Okay, again we can see that 3 times 2 is 6, so times the numerator by 2 to get 4. Equivalent fractions. Okay, so let's have a look at these two here now. Okay, sorry, excuse me. Have a go, pause the video. Have a go at these two. So, to work out what you're timesing, sorry about this, to see what you're timesing the denominator by, you do, for this one, 15, how many 5s go into 15? 5 times 3 is 15, so you times the top by the same number, 3, and you get 9. Okay, next one. What do you times 7 by to get 14? Well, 14 divided by 7 is 2. So you times the top by 2. Okay, this one. What do you times by? 20 divided by 4 is 5. So we times the top by 5 to get 15. Right, you might have something like this, where this time you have to work out the denominator. Exactly the same method. You just start on the top. 6 divided by 2 is 3. So I have to times the numerator by 3. This one here, 20 divided by 4 is 5. So I times the top by 5 to get 45. Okay, so you're going to have a go now. I'd like you to do these 6 questions, please. Just write them out. Write them all out in full. Write down what you're timesing by, please. Okay. I want you to be absolute experts at finding equivalent fractions. So write out each question, fill in the blanks, take a photo and email to if I'm your teacher, to me, or if another teacher is using this video, to your other teacher. Okay, so I'm not going to go through those now. That's 6 questions as your starter to do. Right, so the rest of the lesson. We're going to look at adding fractions, and for this we are going to use what we used in our starter activity. So let's say you had this. You wanted to work out, sorry, I just need to put this under here so the pen doesn't go through. You've got to add these 2 fractions together. So you can see here I've got a quarter of a cake plus another quarter of a cake. So I've got this quarter plus this quarter, we can see it's 2/4 of the cake. So the denominator stays the same and the numerators we add. We could simplify that to a half, divide top and bottom by 2. Okay, so that's adding fractions. So if, for example, if I had this fraction to add, say 2/5 add 1/5, the denominator stays the same. It doesn't change to 10. We don't add the denominator. It's a common mistake some people make. And we get 3/5. Okay, so you're going to have a go at doing these 3 questions. Pause the video. It's a very quick, very easy, I think. And I'm going to go through the answers now. So add the numerator, denominator stays the same. Add the numerator, denominator stays the same. 4/8, 3 add 1 is 4. You could simplify it to a half. These 2 you can't simplify. Okay, now you can see that when we're adding fractions here, the denominator is the same in each circumstance. But what happens if the denominator is not the same? So for example, here we have different amounts of fractions. Here you can see I've got 1/3 of a cake and I'm adding 1/4 of the cake. So how would I do this? Now the problem is the denominators are not the same. So what do I do? Okay, so key note, write this down. Impossible to add fractions if the denominators are different. Well, it's impossible to do it straight away, but we need to change each of these fractions into a number that they both go into. Well, 3 and 4 both go into 12. Yeah? In fact, the lowest common multiple of 3 and 4, the lowest number they go into is 12. So what I do is I change 1/3 into 12ths and I change 1/4 into 12ths. And now I use my equivalent fractions. So 12 divided by 3 is 4 times the top by 4. Here I'm going to times by 3. So times the top by 3. So now I've got 4/12 add 3/12. So 4/12 add 3/12 is 7/12. So I've got 4/12 add 3/12 is 7/12. So that is my answer for adding 1/3 plus 1/4. Because if I divide that into 12 parts, not 3 parts, so if I divided each of these into 12, you can see here I'd have 4/12. If I divide each of these into this circle into 12, I would have 3/12. So 4/12 plus 3/12 is 7/12. Okay, now I know you've done this before, but it's something that students always get wrong in their exams. Right, so let's have a look at this one. 2/3 add 1/2. Right, if you know this, just pause the video and do it yourselves, and then just check your method with my method. Okay, so you have to ask yourself, what am I going to change both of these fractions into? Okay, so you say, well, what's the lowest number that 3 and 2 go into? Well, they both go into 6. 3 times 2 is 6. Then you're going to use equivalent fractions, times 2 times 2. So I get 4 on the top. 2 times 3 is 6, times 3, 1 times 3 is 3. So now my question becomes, so it was 2/3 add 1/2, but 2/3 is 4/6 and 1/2 is 3/6. So I'm adding these, the denominator is the same, so I can do it, and I've got 7/6. You can leave your answer as that, or you could change it to a mixed number. 6 goes into 7 one whole time, with 1 left over. Okay, so pause the video and have a go at this question. Okay, well done. Let's see how you did on this. So I need to change 2/5 and 1/3 into fractions that have the same denominator. Right, so the denominator is going to be 15 because 3 times 5 is 15. Okay, so what goes on the top of each fraction? I times this by 3. I times this by 3, just using what we did in the starter activity. I times this by 5. I times this by 5. So now I'm doing 6/15 add 5/15. Yeah, because this is equal to 6/15, this is equal to 5/15. I add them up. The denominators are the same, so I can do the question. 11/15. Right, I think I'll do one last example. I'll do this one here. So you have a go at doing this on your own. Pause the video and then I'll go through it. So one last attempt. Okay, so well done for doing that. So let's set our work out. We always set it out the same way. Going to give myself a bit more space for this one. Right, so what do 4 and 5 both go into? They both go into 20. Now I'm going to ask myself, what do I times top and bottom by? Well, to get my equivalent fraction, 20 divided by 4 is 5. So I times the top by 5 to get my equivalent fraction. I'm going to times by 4. I'm going to times by 4. 2 times 4 is 8. So my question now becomes, so that now the denominators are the same, I've changed it into something I can add. Denominators are the same, it stays 20, and the top 15 add 8 is 23. So I could change that, that's fine as an answer. I can see it's a top heavy, or what we call an improper fraction. 20 goes into 23 one whole time with 3/20 left over. Right, well done for listening to this video. Now it's your little learning check that I want you to send to me, please. These are the questions I'd like you to do. Just going to check you can see all that. Yep, that's lovely, just put it straight on there. So, I'd like you to show all your method, please, for these 4 questions. There's only 4 questions to do. Take a photo. You must show me your method. I don't just want an answer, please. I want you to show me your method like we did on here. Okay? So look back at the video, look at the method that I've used. And I look forward to seeing those questions handed in to me today, please. Thank you very much.